Chapter 1: The Basics of Quantum Tunneling. In this chapter, we will introduce the concept of quantum tunneling and provide some historical background on its discovery. Quantum tunneling is a phenomenon that occurs at the subatomic level, where particles such as electrons or protons can pass through barriers that would normally be impenetrable according to classical physics. In other words, a particle can cross an energy barrier even though it doesn't have enough energy to overcome it. The phenomenon of quantum tunneling was first discovered by the German physicist Friedrich Hund in the early 1920s, who was studying the behavior of atoms and molecules. Hund realized that sometimes particles would pass through a barrier even though they did not have enough energy to climb over it, and he proposed that this was due to quantum mechanics. To understand quantum tunneling, we need to look at the wave-particle duality of subatomic particles. According to quantum mechanics, particles can behave as both waves and particles at the same time. In the case of tunneling, a particle is described by a wave function, which represents the probability of finding the particle in a particular location at a particular time. The wave function of the particle spreads out on both sides of the energy barrier, and there is a non-zero probability of finding the particle on the other side of the barrier even though it doesn't have enough energy to overcome it. The concept of quantum tunneling challenges our classical understanding of physics, where we would expect that a particle needs a certain amount of energy to overcome an energy barrier. In quantum mechanics, however, particles can tunnel through barriers due to their wave-like behavior. This has important implications in many different fields, including electronics, nuclear physics, and even in the human body. In the next chapter, we will delve deeper into the quantum mechanics behind tunneling and explore how it differs from classical physics.